Okay, good evening, distinguished panel and the audience. This one, a new metric for the estimation of dynamic PCUs in an intersection and heterogeneous traffic. This is a part of a big research that I'm carrying out. The literature review part of this one, of course, I presented in TRF 2024, and here what I am going to do today is present part of my method formulation and a case study that I have done based on this. So I'll just give you an introduction when it comes to traffic signal design. So there are so many problems that we are having, especially in developing countries, because our signal design manuals, they are being developed in developed countries. So the conditions that they have considered, like the compliance of lanes and the headway and all these things, they are not present in our countries. So that is the main problem. There are the challenges are like diverse vehicle compositions and speed characteristics and the traffic culture variations. So there is a research gap. What is this research gap? That is the lack of studies addressing the impact of classical design manuals on heterogeneous traffic. So whether they are going to work here. Now as an engineer, what I know is, no, they are not going to work here. That is why these things are going to fail. Now, there are two parts of this problem. What is these two parts? The part one is how we are going to collect the real-time traffic. For that, there are so many solutions. So you can have some cameras and you can have on-site cameras, drones, whatever. There are so many answers. Part two is, even if we have the real-time data, what we are going to do with that. There comes the problem. And this is an effort we are going to solve it. How we are going to solve. So the study objective is resolve issues related to traffic management in oversaturated conditions, develop innovative practical methods for managing traffic. So if we go to classical method limitations, we are considering PCUs that like passenger cars. So we are going to convert everything into PCUs. The problem is, if this is okay, is it okay to convert all these into PCUs? Now, sometimes if we consider an intersection, most of the vehicles we are seeing here are three-wheelers and motorcycles. So we are converting everything into a non-existing entity. Is this correct? So then in that case, I'm going to introduce, I'm going to introduce three concepts: standard vehicle unit, intersection traverse time, and temporal area occupancy. So many research, they have found out in the literature review, we can see that PCUs are dynamic. So that is why, so how we are going to cater for this dynamic nature of the PCU. So for that, I am going to introduce some three concepts, this SVU, ITT, and TAO. So I'll just go to the SVU. So here I am going to select the vehicles having the highest proportion. That may not be a car, maybe a three-wheeler, a motorcycle, or maybe a car at all. And then this supports with the literature review in Nguyen's HD. They are converting everything into MCU in Vietnam because the motorcycles are heavy there. And then intersection traverse time. Intersection traverse time means I am going to measure the time a vehicle takes to come from intersection tail to intersection mouth. That is not to cross the intersection. Coming from tail to mouth, where the intersection starts to the start of the intersection. Then the time taken that we can measure. So here you can see that this is the intersection area and the time taken for each vehicle to come from tail to mouth. Then it is very much necessary to identify the proper area. And then temporal area occupancy. Temporal area occupancy is that area that is being occupied by the vehicle when traversing this area, this length. And then temporal area occupancy, I am going to get it as L dash into W dash into Ti, that is effective length into effective width into the time taken to traverse. And with that, I am going to consider the proportion of a standard vehicle to any vehicle of this standard vehicle unit, that is the temporal area occupancy of any vehicle into temporal area occupancy of the standard vehicle. Then I am going to define a heterogeneity index, that is the standard vehicle unit, the accumulation of the standard vehicle unit divided by 1900, that is the standard saturation rate that's given in HCM. So that gives, here I am going to quantify the heterogeneity of an intersection. So with that, I took a case study in Palantuna Junction, and with Palantuna Junction, what I did was, there I measured all these things. So I measured the vehicle length, vehicle width, and the safety gap they are keeping, and these things I measured. And then I had a data set, that is that data set in the video set, that shows how the vehicles are moving. Then what I did was, when a vehicle starts at the intersection, I took that time, and then the vehicle passes the intersection, I took that time, and that is the traverse time. So with that, I now taking my earlier defined parameters, I could come up with PCU factor. So I'm telling here PCU because the major vehicle type was cars there. So here, one thing you can see here is, you can see that motorcycle, it comes like 0.2. So that is very important. Now in RDA we consider it as 0.5. And we are having, in signal calculation, we are having very long queues, but they are actually not there in the site. So I can explain why it is happening with this one. And then I calculated saturation flows, and based on that, I back calculated to check if it is 1900, what should be the PCUs. So why did I do like that? Because I'm going to give a concept saying that in an intersection, the vehicles arrange themselves to maximize their flow. Not in the space, temporarily and spatially, they are arranging themselves to maximize the flow. That is their intention. So if that is the maximum flow, if we take as 1900, then these PCUs are coming. But then the problem is, if 1900 is the maximum flow. So, but what I can say is, if that heterogeneity index is going above 1, of course we have to consider that value, and then again back calculate to check that one. So this is here we can see in some cases the heterogeneity index has gone above 1. So that means we have to take the maximum of this and then back calculate to check the PCU values. Then with this one, we can establish the dynamic nature of the heterogeneous traffic. Then vehicles organized in time-space continuum to enhance flow. And this is how Chandra's method is taking place and things. And my conclusions are, current saturation flows offer improved estimates over classical manuals, and SVU PCU values are tailored to the specific cost of the intersection here. So for each and every intersection, we have to do it. So this research is not finished. I have to justify this with many other junctions and with many other geometric parameters and all these things I have to justify. And with simulation, I have to check whether this would work. So with that, what I am going to do is, if this is going to work, I am going to have some AI and ML means artificial intelligence and machine learning program to do this on site. And with that, I am going to give the traffic signal. Thank you very much.
Thank you, Mr. Alvidano. You have perfectly consumed the time given. And about the PCU research, I think it's ongoing. There are multiple researchers looking at suitable factors for Sri Lanka. So I think this is a required research. Thank you.